Good day, guys. Yeah, welcome back to our mathematics class. Lesson 3 of indices. I believe we are flowing as we are taking it step by step. Just before we dive into this lesson proper, if you have not subscribed to this channel, kindly do so and click the notification bell. And don't forget to share to other learners to benefit. Now, example 1, you want to simplify this. The first one, 9 raised to power 1 over 2. Don't forget, it's going to be equals to the square root of, draw your square root first. Then this 9 will be in this cup. This 2 here is supposed to be here. But we cannot put this 2 here because this 1 over 2 means square root. So in putting that 2 here, we are doing repetition. So square root itself means 1 over 2. So if you now put 2 here, it means 1 over 2 times 2. 2 will cancel 2, it's going to be equals to 1. So that's the reason why the 2 will not be there when we have a base of 2. Then brackets raised to power 1. Now, the meaning of 2 that is here means find two numbers that when you multiply the numbers together, it will give us 9. Equal numbers, when you multiply together, it gives us 9. It's going to be square root of 3 times 3 raised to power 1. Now, you pick one of these 3. So you're going to have 3, the raised to power 1. But when you are removing this square, as if you are looking for the square root, you are going to introduce plus or minus. Meaning our answer could be positive and also be what? Negative. Raised to power 1, which is plus or minus 3. So our answer can be plus 3, it can also be minus 3. So if you say plus 3 times plus 3 give us that plus 9. Minus 3 times minus 3 give us plus 9. That is the reason why it is plus or minus 3. B. 8 raised to power 1 over 3. Here we have your cube roots, your square roots. Then this 8 will be here. Now this one is 3. You can put it here. That is, we call it cube root now. We call it cube roots. So when you put it there, we now have the upper number 1. So this 3 means what you can multiply in 3 places to give us 8. So we have 2 times 2 times 2. Don't forget your cube roots. Raised to power 1. So you pick one of these. To find the cube root mean pick one of these 2. 2 raised to power 1. So we have 2 raised to power 1 give us what? 2. C. 8 raised to power minus 2 over 3. Don't forget, the first thing you deal with, if you are given an indices like this, is the negative. The negative is the first one you target. And the negative will change to what? 1 over. So we have 8 raised to power 2 over 3. So the next step is now to change it into your square root or cube root. So we have 1 over, then this 3 will be here, 8 will be here, raised to power 2. So we have 1 divided by, so this 3 means what you can multiply in 3 places to get 8, 2 times 2 times 2, raised to power 2. So we have 1 over, so you pick one of these 2, 2 raised to power 2. So which is 1 over, 2 raised to power 2 is what? 4. Question D. 4 raised to power 1 over 6 times 4 raised to power 1 over 3. This is like the first law of indices that says x raised to power a times x power b. Pick one of these base, x power a. Multiplication changes to addition plus b. They have the same base. Pick one. 4 raised to power 1 over 6. This changes to plus 1 over 3. This is a fraction. We have to change it to one fraction. Let me say, find the LCM of 6 and 3. We have 6. 6 goes in 6, we have 1. 1 times 1, 1. Plus 3 goes in 6, 2. 2 times 1, 2. So we have 4 raised to power 1 plus 2, 3 over 6. 3 here, 1, 3 here, 2. So we have 4 raised to power 1 over 2. Now we are back here, which means it's going to be equal to square root of, this 4 will be here. I don't need to put the 2 here. but we put it per what? 1. So the meaning of this 2 that is here means what you can multiply in two places to get 4, 2 times 2. Put your square root, raised to power 1. Then you pick one of the two, 3 raised to power 2, which is equals to what? 2. Now, I want to simplify the first question. Open bracket 2 whole number 1 over 4 raised to power 1 over 1 over 2. The first thing to do is to change this from mixed fraction to improper fraction. So we have 4 times 2, 8, plus 1, 9 over 4, raised to power 2 times 1, 2 plus 1, 3 over 2. We have 9 over 4. Then these two, those are supposed to be here. Then raised to power 3. So the meaning of 2 here means once you can multiply in two places to give us 9, and also in two places to give us 4. We are going to have 3 times 3 divided by 2 times 2. Back your square roots, raised to power 3. So from here, you pick one of these 3 over, pick one of these 2, 2. Because see, these 9 and 4 are perfect squares. So you have to introduce plus or minus. Then raised to power 3. So this 3 means we are going to multiply this in 3 places. So we have plus or minus 3 times 3 times 3 over 2 times 2 times 2. So plus or minus 3 times 3 is 9. 9 times 3, 27 over 2 times 2 is 4. 4 times 2 is what? 8. So we have plus or minus. How many 8s can we see in 27? We are going to have 3. That is 24. Remainder 3. 3 over 8. So that is how to go about the steps. Question B. 8 divided by 50 raised to power minus 1 over 2. The first thing to deal with is what? Yes, you get it right. Minus. So the minus will change to 1 over 8 over 50 raised to power 1 over 2. So we have 1 over. So 1 over 2 becomes square root of 8 over 50. So you don't need to put your 2 here. Raised to power 1. Now, this 2 that is here means you're going to find two values that when you multiply in two places to give us 8 and also give us 50, we cannot get a values like that. Instead, look at what can go in each. 2 goes here, we have 4. 2 goes here, we have 25. So we can now find the two values now. It becomes 1 over 2 times 2 over 5 times 5 square roots. So raised to power 1. So when you put these two and one here, one here, we're going to have 1 over 2 over 5 raised to power 1. So we're going to have 1, these 2 in one place, 1 over 2, divided by 5 in one place, 5. So we now have this one, then this division divided by 2 over 5. So let's say over 1 here. So we have 1 over 1 multiplied by, so when you must change this to multiplication, 5 will go up, 5 over 2. 1 times 5, 5 over 1 times 2, 2. So how many 2 can we send in 5? We have 2 whole number 1 over 2. The next question, square root of 72 a raised to power 3, b raised to power minus 2, divided by 2 a raised to power 5, b raised to power minus 6. Let me do it this way first. 72, multiplication is joining them together, a raised to power 3, multiplied by b raised to power minus 2, divided by 2 times a raised to power 5 times b raised to power minus 6. Then you put square roots. 2 here, 1, 2 here, 36. So we're going to have 36. This is a, this is a. Let me pick 1a times a raised to power this 3. This division here changes to what? Minus. Then you put your what? 5. Times again. Take one of these b raised to power minus 2. This division as well changes to what? Minus. Then minus 6. Then put your square roots. So we are going to have 36 multiplied by a, 3 minus 5, we have minus 2, times b raised to power minus 2, Plus minus times minus, we have plus 6. Put your square roots. So we have 36 times a raised to power minus 2 times b raised to power minus 2 plus 6, we have 4. Put your square roots. So we now have, this square root is for everything. Square root of 36 times square root of a raised to power minus 2 times square root of b raised to power 4. So we have, when square root of 36, we have 6. So we have plus or minus. See, it is a perfect square times, you can't find the square root of this. So we have a raised to power minus 2. This square root means times 1 over 2. Don't forget, 1 over 2 initially is the one that used to change to square roots. So we now have b raised to power 4 times this square root change to 1 over 2. 2 cancel 2. 2 here, 1, 2 here, 2. So we're going to have plus or minus 6 times a raised to power minus, this one remains 1, times b raised to power 2 times 1, 2. Now from here, we are not yet 2, plus or minus 6 times, this minus here changes to 1 over a times b raised to power 2. See, this one has over a, let's say over 1 here, over 1 here. So we're going to have plus or minus 6 times 1, 6 times b squared, 6b squared over 1 times a, we have a times 1, we have what? A. So this is our final answer. So this is the best way of approaching indices questions. So if you have any difficulties in solving what we have done so far, you can throw it in the comment section below.